Okay, I'm going to start with this table again. So we saw this table in the scientific figures video. And the reason why I want to use it here is because these values, the distance from the sun and the distance from the earth, have been rounded basically. And they've been rounded using significant figures. Now, if I go to this table here, you can see, don't worry about this column here. It's amazing what you can find on the internet. Sometimes you just don't get what you want. So just ignore this one here. And let's look at this column here. So what we have are the values, all the values are there. And compared to this one, where it's been rounded. So if we look at Mercury, we have 58 million. But here Mercury is measured as 57,910,006 kilometres. So you can see why you would round it here, because it's a lot easier to just say, oh, 58 million. So we're basically rounding to the nearest million, but we also call it significant figures. So two significant figures. So for Mercury, if we were rounding to significant figures, and let's just do two because that's what the other one was. We look at the first two numbers. Okay, so we have the first significant figure. Then because we're doing two significant figures, this number is very important. Okay, the 7, because it can be rounded. Now, because the next one, and if you want to just say, all right, there's our two significant figures, and then this number here, 9, determines whether that 7 gets rounded. And it does, okay, because we round up to 58. So the two significant figures are 5 and 8, and then we just write the zeros. So we call these zeros non-significant. Okay, so only these two values here that are significant. All right, let's just have a look at another planet. So you can see here, and these distances might not be exactly the same. Let's see what they've done for Neptune. Okay, so I'm just trying to see. Let's go to Mars. Okay, so Mars, let's just get rid of that. So I'm choosing one because, I mean, we're dealing with long distances here, so they're not always going to be the same numbers. All right, so let's look at Mars. We have 227,939,920. Now, if my friend said to me, how far is Mars from the sun? I'm not going to say 227,939,920 kilometres, because they're probably not going to test whether it is exactly that. I might say, oh, it's about 200 million kilometres, or I might say 227 million kilometres, but I'd actually round that out up to 228 million kilometres. So if I just go back to the previous table, let's see what, no, it's not Mars, what are we doing? Is it Mars? Yeah, oh, look at that, circling the same planet. 228 million. So just quickly, how many significant figures have they rounded this to? If your answer was 3, well done. So if we round this to 3 significant figures, I write the first 3 significant figures. Well, the first 2. And then the third one, we've got to say, well, does it get rounded? And it does, because this 9 means it gets rounded up, so it's 228. So they're our significant figures, and then the zeros aren't significant. Okay, but we still got to put them on. Now, there are rules for significant figures, okay, and I'm going to show you what they are, but the best way to do significant figures is actually just to practice them, because they're not really that difficult. It's just an understanding of, well, what is significant and what isn't significant. Okay, so here's a little table. I don't really need to make that bigger. No, I'll make it a bit bigger. Okay, so you can see the rules down the side here. Okay, so our first rule one there. All digits other than zeros are significant. Okay, so in these two examples, we don't have any zeros anyway. So we've got listed here how many significant figures. Well, there's 2. It doesn't matter about the decimal place in this case. There's 4 significant figures. So if you had to round something to 4 significant figures, we include the integer and then the decimals. All right, zeros between non-zero digits are significant. So what that basically means is zeros that are in between other numbers are significant. Okay, so this will make more sense later. So when we're looking at the number of significant figures, this is 3 and this one's 4. Final zeros to the right of the decimal are also significant. Okay, so if we were rounding this to 3 significant figures, we actually need to write 6.00. Now, even though we know that's the same as 6, we need to, I guess, in chemistry, when you're dealing with, when amounts are extremely important, you wouldn't just say 6 because someone might think, well, is it 6 or could it be 6.2 or 6.45 or something like that? So you're basically telling the person, okay, it's 6.00. It is exactly 6. So it's 3 significant figures. So we do include the zeros after the decimal. Okay, and then here we've got 4 significant figures as well. So the same reasoning. Okay, oh, didn't label these. You can label them 1, 2. 1, 2, 3, 4. Okay, so in numbers smaller than 1, zeros to the left or directly to the right of the decimal point are not significant. Okay, so not significant. So if we were doing 0.05 centimeters, we only have 1 significant figure. We don't count these zeros beforehand. Okay, and the same here. So we don't count those 2 zeros here, but we count the 0 at the end. Okay, so the zeros merely mark the position of the decimal point. And here the first 2 zeros mark the position of the decimal point, but the final 0 is significant. All right, I tried to find a worksheet. Oh, sorry, here's another one. Okay, so I just Googled and spent a lot of time Googling trying to find the best things. Okay, so here are some examples, and this is good to have in your bound reference just so you can think, oh, I can't remember, do I include those zeros? Well, here are some examples. So 1.03, okay, so remember the 0 in between we include as a significant figure. So here we have 3 significant figures. In the second one, we don't include any zeros leading up to the integer or the number, the non-zero number. So in this case, we only have 2 significant figures, the 3 and the 4. We don't count these as significant. So even though we write them, okay, the reason why they're called significant is because it's different to rounding. Rounding, we, if we were rounding this to 2 decimal places, it would be 0.00, and I'm basically saying, well, that doesn't exist. But if I said 2 significant figures, I've got to include all those zeros and then 3, 4. So extremely important, as I said before, in chemistry when measurement, in all aspects of mathematics as well, but you need to actually show, well, it is there, it's not 0. Here we have 1 significant figure, so the zeros beforehand are non-significant, 1 significant. Now, this one here, we can see 3.00. If you've got a decimal place, anything after that decimal, assuming that there's a number here that is not 0, is significant. So 3.00, 3 significant figures. Whereas you can see this 30, there is no decimal place. So that is to 1 significant figure, which differs to this one here, where you've got a decimal place, okay? So you're probably thinking, why are they different? So this one here, if I'm just saying 1 significant figure, then this could be, a variety of numbers. I could have rounded it to 30, whereas this one here is clearly saying it is 30, okay? So let's just say if I had the number 28 and I had to round that to one significant figure, it would be rounded to 30. But if I had, say, the number 30.245 and I had to round that to two significant figures, it would be 30, including the decimal. Okay, so you can see, the difference of between the two. Okay, oh, and just say if I had 28 to two decimal places, sorry, two significant figures, it would be 28 with a decimal. Okay, so a bit of a difference between the two. So no decimal place, one significant figure, decimal place, two significant figures. The 3 on its own, one significant figure. Here we have zeros in between and a 0 at the end, so they're all included. So we have 5 significant figures, and here we've only got zeros in between, so also 5 significant figures. All right, so I found a worksheet, but it moves a bit on me. So if I can move my hand somewhere where it's not in the way. Okay, so, and the answers are there, but that's okay because it'll get you thinking about the question. So you can see this one here applies the same rules that we went through before. God, I almost pointed at the screen, isn't that bad? So I can't point at anything without it actually moving, so I'm going to have to just, that's why I was pointing. But we will just go through them anyway. So question 1, 1.02. So remember, any zeros before are not significant. And that's also the case in question 2, where we have 2 zeros before, they're non-significant, but the 0 after the 2 is significant. That's why it's 2. Question 5, we have 5,000. So the 5, because there's no decimal after the 0, okay, it's to one significant figure compared to 6 and 7 where there are decimals. Okay, so you might want to add a few of these examples in to the previous one, so you can actually say, oh, this is when the zeros are included and when they're not included. Okay, now next one, we have round each of the following to 3 significant figures. Okay, so you can see here how rounding is applied. So the first one, we just have 804 as our significant figures, and then we replace the 1, 2 with 0, 0. So we've got 3 significant figures there. Question 17, you can see a bit of rounding done, okay, and so forth. So 19, we've got some scientific notation in there as well. Okay, so we're only rounding the numeral part of it. And I'm just trying to see if there's anything else that is quite interesting. See question 21 and 20. So 20 rounding to 3 significant figures. It's not 599. It's got to round up to 6, and it's 6.00. So it's important that you put that 0.00 in, and then otherwise it would be one significant figure, and then 21, and we've got 1.30. All right, and then the next one, we're just adding things, so we might just leave that. All right, oh, stop moving. All right, so just looking at this worksheet here, so we've got some rounding to 1 significant figure and 2 significant figures, and you can see how dramatically, just in the first example, how different, so how dramatically different these can be depending on how many significant figures you have to do it to. So the number 1,628, if we were doing it to 1 significant figure, we need to look at the first number, which is 1, and say, all right, so it's just 1 significant figure, so we're just looking at the 1. And the number next to it doesn't mean it rounds, and it does. Okay, it has to round up because it's a number that is greater than 5. So that's why it's rounded to 2,000. When we're looking at 2 significant figures, we've got to look at, okay, so we keep the first one, but it's the second significant figure that could be rounded. And in this case, because the 2 doesn't mean it rounds up, It stays as 1600. All right, so let's have a look at a few of these. All right, we're only doing one significant figure and two significant figures, but hopefully by just doing this worksheet, you will understand, well, I can do 3, 4, 5, however many significant figures you throw at me. Okay, so round to one significant figure, we always look at the first number. So I'm just going to circle a few of them. A few. Okay, I want to do some 0 ones. Okay, so how about we leave it at that? Okay, so then we say, all right, does the number next to it mean it rounds up? Well, this one's a 4, so no, it doesn't round up, so it's just 200. This one's 2, so it doesn't round, so it's just 5,000. This one's 6, so it rounds up. So similar to the very first number. This one is 8, so it rounds up to 20. Here it is 3, so it doesn't. Now remember, you can just leave it as 5. So it's just one significant figure. 2.73, so write that as a 3. 0.7. Okay, so remember the 0 is non-significant, so we have to then go to the 7. Okay, so remember we don't worry about any zeros. So this, but we do have to put in the zeros, but they're non-significant. Okay, and then the 7 is our significant number. Does it get rounded? No, so it's just 0.7. This one here is the same. We're looking at the 3, not the 0, because the zeros are not significant. So we've still got to put them in, but they don't affect the number. So it's just 3. All right, the next one. So we're looking at the 4, so 0. And that gets rounded to 0.5. This one here, we've got 2 zeros. Okay, so we don't worry about them. This is the number we are looking at, and that gets rounded. Oops, I was about to write 9 to 2. What a beautiful 2. Okay, same one here, 0.0, and 7 doesn't get rounded, and you can't see past this one, so I may as well just do this one. So this one's 4,000. Okay, so we're just remembering the zeros. Okay, so we don't worry about any zeros to the left. We've got to think about, well, what's the first non-zero number? All right, I'm going to clear that. All right, let's do 2 significant figures. Now we always keep the first significant figure. It's only the second one that gets rounded. So the 4 gets rounded up to 5. This one doesn't get rounded. Everything else just becomes 0. So 1600. This one stays as 18. This is 5.4. 2.7. Remember the zeros don't count, so this one's 0.73. We don't include the 0, so it's 0.32. 0.46. Don't include the zeros, so it's 1.8. Don't include the zeros, so it's 7.4. And the last one is 3,800. All right, if you were doing 3 significant figures, how about we just add that one in as well? So let's just okay, so don't worry about that one. So 3 significant figures. We keep the first 2 significant figures, and it's the third one that can change. Can it change in this one? Yes, it does. So it becomes 30. 247 just stays as 247. 5.2, the first 2 significant figures don't change, so we look at the 0. Does that 0 change? Yes, it rounds up to 1. And I'm going to keep going until we get to a difficult one. Okay, 18, that's 2 significant figures, so we have to add in a third significant figure. This one is already to 3 significant figures, so is the next one. So the next 3. Okay, so these are all 3 significant figures already. Okay, so I'm not going to write them. This one is also, okay, and so is this one. Okay, so all these well, already to 3 significant figures. And that's because we don't worry about these zeros. Okay, so they're already to 3 significant figures. So remember, we still write the zeros. Okay, so let's just write this one down here, 0.0, but it's the 3 numbers that come after that counted. And then the last one is 3850. Okay, so hopefully you understand significant figures. You do need significant figures and when you go on to do further maths, definitely, but also, again, in science and methods and specialists as well, and an understanding of how to read numbers in general.